Welcome back. Today, we are going to tear down the architecture of a really sophisticated, multi-talented WhatsApp agent. We're going to break down, piece by piece, how you can build an AI that doesn't just talk, but also sees and remembers, all right inside the messaging app you use every day. Now, take a look at this. This isn't just some generic chatbot response. This is a direct quote from the AI agent we're about to pull apart. It was asked to write a poem about the user's name, which it remembered from way earlier in the conversation. Pretty amazing, right? This one little example shows off its creative muscle and, maybe even more importantly, its long-term memory. So let's just quickly break down what makes this agent so special. It really has three core superpowers. First up, it handles conversational text, just like you'd expect from any powerful language model. Second, it's got vision. It can literally see and describe images you send it. And third, the real kicker, it has long-term memory, keeping track of your unique conversation from start to finish. So that brings us to the big question, right? How on earth does a simple text or a picture you send through WhatsApp connect to this whole complex system and get such a smart response back? Well, let's pull back the curtain and see exactly how this whole thing is wired together. Okay, let's start with the absolute heart of the operation, the brain. And in this case, the brain is a framework called LangGraph. The best way to think about it is like the conductor of an orchestra. It doesn't play every instrument itself. Nope. Instead, it directs the entire show, telling each specialized part what to do and when to do it. What's really clever about this setup is how it gets its superpowers. It's not about using one giant do-it-all model. Instead, it delegates. And this is a really smart design choice. LangGraph uses two different specialists: a chat agent, which is a text-only model that's perfect for just talking, and a vision agent, a completely different model built specifically to understand images. This makes the whole system way more efficient. So how does LangGraph know which specialist to send the job to? Well, that's the role of a little component called the supervisor. You can seriously just think of it as an air traffic controller for data. It looks at every single incoming message and asks one simple question: is there an image in here? If the answer is yes, boom, it routes it to the vision agent. If no, it just goes to the chat agent. That simple decision is what makes the whole thing work so intelligently. And what about that incredible memory we saw at the beginning? The solution is actually super simple but really elegant. The system uses a simple SQLite database. It's a lightweight, self-contained database that's perfect for this because it doesn't need a whole separate server. Every time a new person messages the agent, it just creates a unique conversation thread tied directly to their phone number. This keeps your chat history totally separate and secure from everyone else's. Okay, so we've got this intelligent brain built with LangGraph, but right now it's just a bunch of code running on a computer. It's totally isolated. How does it actually connect to the outside world to get a message in the first place? That's the next big piece of the puzzle. The connection is basically a two-part system. First, we use a tool called Fast API to build what you can think of as a digital doorway on our computer. It's an API endpoint that's just sitting there, always listening for messages. But this doorway is private. It's only on our local machine. So to open it up to the world, we use a second tool called LangGraph. LangGraph is an amazing service that builds a secure tunnel from the public internet directly to that private doorway, letting messages from the outside safely reach our code. All right, we've connected our brain to the internet, but we still haven't actually connected it to WhatsApp itself. And you can't just plug an API into WhatsApp. It's a closed system. That's where the final piece of this whole communication puzzle comes in, a service called Twilio. You can think of it as our digital post office. Twilio plays a few really critical roles here. First, it gives us a programmable phone number that actually lives on WhatsApp. When you send a message to that number, Twilio gets it first. Then it does its most important job. It forwards all that message data to a URL that we give it. And which URL do we give it? You guessed it, our public LangGraph tunnel address. Finally, when our agent spits out a reply, Twilio is the one that takes it and delivers it right back to the user on WhatsApp. And here's a really cool technical detail about how images are handled. When you send a picture, Twilio doesn't actually send the image file to our app. Instead, it sends us a URL that points to where the image is stored. Our code then has to grab that URL, download the image, and convert it into something called a base64 string. That's basically just a way of turning an image into a giant wall of text, which is the only format the vision model can actually read. Okay, we've met all the players in this system. You, the user on WhatsApp, Twilio, the gateway, LangGraph, the bridge, our local API, and of course, the LangGraph brain with its specialist agents. So now, let's put it all together. Let's follow a single message on its complete journey, from your phone to the AI and all the way back. So it all starts with you, of course. You type a message or you send an image in your WhatsApp chat. That message zips through WhatsApp's servers and gets delivered to that special programmable phone number that's being managed by Twilio. The second Twilio gets that message, it immediately forwards it on to the public URL we configured. That's our ngrok tunnel. ngrok then securely channels that data from the public internet through the tunnel, and it arrives safely at the Fast API server running on our own machine. The message has officially crossed the bridge. Now our Fast API server has the data, and it hands it off to the brain, LangGraph. The supervisor function immediately inspects the message, figures out if it's text or an image, and routes it to the correct specialist, either the chat or the vision agent, to get to work on a response. So once the specialist agent has done its thing and crafted a reply, whether that's just text or a full description of an image, it hands that response back through the LangGraph framework. LangGraph then passes the finished reply back to our Fast API server, and it's ready for its return trip. And the journey home is just the reverse of the trip in. Our server sends the response back out through the ngrok tunnel, all the way to Twilio. Twilio then takes that response, packages it up as a standard WhatsApp message, and delivers it right back to your phone. The entire round trip is complete, usually in just a few seconds. So there you have it. That's the full architecture, from a simple message all the way to a complex, memory-powered AI response and back again. The tools to build agents just like this are becoming more and more accessible every single day, which really just leaves us with one final big question. Now that you know how it's done, what would you build? What would your personal AI agent do?